Welcome to Nebulity Learning Center. Stoichiometry is part 1. Here are the learning goals. Students will be able to describe the purpose of stoichiometry for our daily life, explain the stoichiometric conversions such as mole-mole, mass-mole, and mass-mass, describe the relationship between mass ratio and mole ratio, and the coefficients present in a chemical reaction, represent how coefficients and subscripts are connected to the amount of reactants, analyze the methods to calculate stoichiometric problems. Stoichiometry in everyday life. What does stoichiometry mean? First, stoichiometry is one of the most important concepts in chemistry. The term comes from two Greek roots, stoichion, which means element, and metron, which means measure. The stoichiometry is the science of measuring quantities or mass ratios of chemical elements in a given chemical reaction. Stoichiometry is applied in our daily life. It is applied in food preparation. Food preparation is an appropriate analogy to understand stoichiometry. For instance, a recipe for making 8 pancakes requires a cup of pancake mix, some milk, and an egg. The equation representing the preparation of 8 pancakes is 1 cup mix plus 3,443 cup milk, and 1 egg will give 8 pancakes. How many cup mix, how many eggs, and cup milk required to make 32 pancakes? This is for your assignment. You can calculate the amount of cup mix, cup milk, and egg to prepare 32 pancakes. Next, stoichiometry also is prepared in the manufacturing of cars to be what's safer. Today, automobiles are the main means of transportation of people anywhere in the world. Car companies placed airbags in the steering wheel and other places inside the vehicle to protect people in the event of collision. With stoichiometry, you can know how much nitrogen gas must be produced in a matter of seconds for the bag to inflate by impact and can save the life of the driver or passenger. The third application of stoichiometry in our daily life is help not to get lost. At present, it is normal for people to be located by their GPS to get an address or know if they have a shop or bank near them. This localization system is composed of several satellites in space. Stoichiometry helps us to calculate the fuel, weight, and materials needed for rockets to fly into space, to leave satellites in orbit. In addition, it calculated the fuel and reaction of the satellite components in orbit. Thus, we can enjoy a global positioning system so that we do not get lost. With these simple examples, you can see how daily life is filled with many more scientific elements that we know. The next is stoichiometry. What does stoichiometry mean? It is the quantitative relationship between the amount of reactants used or consumed and the amount of products formed. Stoichiometry also defined as it is the calculation based on what a balanced chemical equation. It is based on what the law of conservation of mass. Okay, all stoichiometric calculations or conversions are calculated or converted by using what a balanced chemical equation. Okay, that's why it is based on what the law of conservation of mass. The law states that matter is neither created nor destroyed in a chemical reaction. That means the mass of the reactants must be equal to the mass of the product in a chemical reaction. That means also it also means that the number of atoms in the reactant side equals to the number of atoms in the product side. Okay, we used a balanced chemical equation for stoichiometric calculation. Okay, a balanced chemical equation. In a balanced chemical equation, there are what coefficient numbers. When we balance a chemical equation, we change the coefficients of the reactants and products only. The coefficients of reactants and products can represent the number of atoms as well as the number of moles that reacted in a chemical reaction. Moles do not directly tell us the mass of the reactants. However, remember that the number of moles can be converted into grams. How can we convert mole into mass? We use this formula. The number of moles equals to given or required mass divided by the molar mass. Or simply, mole represented by what small n, and given or required mass represented by what small m, and big M represents the molar mass of a substance. For example, the molar mass of 1 mole of water equals to 2 mole of water, which equals to 3 mole of water, equals to what? 18 grams per mole. That means 1 mole H2O reacted with, 1 mole H2O equals to the molar mass of 1 mole of H2O equals to 2 mole of H2O, which equals to 3 mole of H2O, and so on, equals to what? 18 grams per mole. What the relationship from a balanced equation, the relationship between stoichiometric calculations and the relationship between reactants and products in a balanced chemical equation. All stoichiometric conversions or calculations are based on a balanced chemical equation. To convert mole into mole, mass into mass, and mass to mass, a chemical equation must be balanced. The number of, for example, iron reacted with oxygen to produce iron oxide, iron 3 oxide. When we balance this chemical reaction, 4 mole of 4Fe plus 3O2 produce 2Fe2O3. That means 4 atoms of iron reacted with 6 atoms of oxygen to produce 4 atoms of iron, 6 atoms of oxygen in Fe2O3 to produce what? 10 atoms. And also, when we see the mass of the reactants equals to what? The mass of the products. The mass of iron is 223.4 grams combined with 96 grams of oxygen gives 319.4 grams. In Fe2O3, the mass of 2Fe2O3 is 223.4 grams iron plus 96 grams oxygen produce 390.4 grams. The number of moles of iron is 4 moles reacted with 3 moles of oxygen to produce 2 moles of iron 3 oxide. Okay, a balanced chemical equation gives us information about the number of moles of the reactants and products, the mass of the reactants and products, the number of moles of the reactants and products, and also the number of molecules and volume of the reactants and products as well. Next, mole ratio and mass ratio. These two ratios are important for stoichiometric calculations. You have to understand what does mole ratio mean and mass ratio mean. Mole ratios, you can use the coefficients in a balanced chemical equation to write mole ratios. Okay, use the coefficients. The coefficients represent what? The number of moles of the reactants and products. Okay, always you can use the coefficient number in a balanced chemical equation to write mole ratios. What does mole ratio mean? Is a ratio between the number of moles of any two substances in a chemical equation. Okay, for example, hydrogen peroxide decomposed to give oxygen and water. Okay, 2 mole, when we balance this chemical equation, 2 mole of hydrogen peroxide is reacted with 1 mole of oxygen to produce 2H2O. Okay, the number 2, 1, and 2 are what? Coefficients. Coefficients of the reactants and products. Okay, what is the mole ratio of hydrogen peroxide to O2? Which is equals to 2 mole of H2O2 over what? 1 mole O2. The mole ratio of O2 to H2O is 1 mole O2 over what? 2 mole H2O. Okay, the numbers are the coefficients. The next is mass ratio. Mass ratio also is important for stoichiometric calculation. You have to understand what does mass ratio mean. Okay, find the mass of each atoms in a compound in a balanced chemical equation. Coefficients multiplied by subscripts gives what? The number of atoms. Okay, the coefficient number multiplied by the subscript gives number of atoms in the reactant and product side. The number of atoms multiplied by the atomic mass of the substance or the element gives what? The mass of the element. Add the mass of each atom in a compound in a balanced chemical equation to obtain the total mass of the substance. A mass ratio is a ratio between the mass of any two substances in a chemical equation. For example, hydrogen peroxide decomposed to give oxygen and water. The mass ratio of, this is mass ratio, and this one also is mass ratio. The mass ratio of hydrogen peroxide to O2 is 68 gram mass of hydrogen peroxide divided by what? 32 gram oxygen. Here, there are what the atomic mass of hydrogen and oxygen are given. Okay. The mass ratio of hydrogen peroxide to O2 is 68 over 32. The mass ratio of O2 to H2O is 32 gram over 36. And also you can calculate the mass ratio of hydrogen peroxide to O2, or you can calculate the mass ratio of O2 to hydrogen peroxide and vice versa. Okay, the next topic is stoichiometric convergence. We can say stoichiometric calculations, stoichiometric problems, stoichiometric relationship. Okay, the same. Stoichiometric convergence. There are different kinds of stoichiometric convergence, but now we have 3: mole, mass, mass. In addition to this, there are also what? Mass, volume, and volume relationships. What does mole convergence or mole problem or mole relationship mean? When determining the number of moles produced from a reaction, you must first begin with a balanced chemical equation. This kind of conversion is the mole of the reactants or products is given, and the mole of the reactants and products will be what's required. Okay, when determining the number of moles produced from a reaction, you must first begin with a balanced equation. After writing your balanced equation, you then need to identify the substance you know and the one you need to determine. Use most ratios to determine the substance that you need to find. Okay, for example, a vigorous reaction between potassium and water produces hydrogen gas and potassium hydroxide. How many moles of hydrogen are produced if 0.04 moles of potassium are used. You are asked to find the number of moles of the reactant, and you have given values, the number of moles of what potassium used. Okay, then you can calculate the number of moles of hydrogen from a balanced chemical equation. The reaction is, the first step is write a balanced equation. The reactants are hydrogen and water. Sorry, the reactants are potassium and water produce potassium hydroxide and hydrogen gas. When we balance this chemical equation, this gives us what? 2K plus 2H2O produce 2KOH plus H2. The next step is identify the given and required, and write the given values at the top of the formulas of what the reactants and products. You have asked to find the number of moles of hydrogen. This is the formula of hydrogen, put question mark here, and the given mole of potassium is written at the top of the formula of potassium, which equals to 0.04 mole. In the third step, moles from the balanced equation. You have to find out the number of moles of the given and required from the balanced equation. Okay, the number of moles represented by what? The coefficient number. The coefficient number of potassium is 2. Therefore, from the balanced chemical equation, the number of moles of potassium is 2 mole. And hydrogen has a coefficient of 1, which means 1 mole of hydrogen will be produced from 2 mole of potassium. And then you can apply the mole ratio method and apply stoichiometric proportion methods. Okay, a combination of these two methods should be applied to find the required number of moles of hydrogen produced. Okay, the mole ratio should be the moles of the unknown over the moles of the known. Okay, 0.04 mole of potassium metal is given, and over what? 2 mole of potassium, which equals to question mark divided by what? 1 mole of hydrogen gas. Then crisscross it. 0.04 mole multiplied by 1 mole divided by what? 2 mole. This produces 0.04 mole of hydrogen will be produced from 0.04 mole of what? Potassium metal. The second method is apply stoichiometric proportion method. Okay, from 2 mole potassium metal, we obtain 1 mole of hydrogen from the stoichiometric proportion or from the balanced chemical equation. Okay, from 0.04 mole potassium, you can obtain X amount of hydrogen gas, and then crisscross question mark multiplied by 2 mole of potassium, which equals to 1 mole of hydrogen multiplied by 0.04 mole potassium. Divide both sides by what? 2 mole, and this will give question mark equals 0.04 multiplied by 1 mole divided by 2, and 0.02 mole of hydrogen gas will be obtained. The next is the mole mass convergence. Now, suppose you know the number of moles of a reactant or product and want to calculate the mass of another product or reactant, and vice versa. Okay, if the number of moles of reactant or product is given, the mass of the reactant or product is required. Or if the mass of the reactants and products given, the number of moles of the reactants and products will be asked to calculate. Okay, we can use these two methods. The first one is the mole ratio method, and the second a combination of mole and mass ratio methods. You can get the number of moles of the unknown. Once you have the number of moles, use the molar mass to determine the number of grams that were produced. Step 1, mole given, divided by what? The mole of the given, or which means the coefficient, mole required or calculated over the mole or coefficient of the required or calculated. Step 2, convert the mole required or calculated into what? Mass. Okay, mole required divided by mole required equals to mass required divided by molar mass. We are based on what? Number of mole equals to given mass or required mass divided by the molar mass of the substance. This method is two-step or long method. In the second method, mole, a combination of mole and mass ratio methods. This is done by using mole ratios and mass ratio from the equation to get the number of moles of or mass of the unknown. Mole given divided by mole or coefficient of what? The given one equals to the mass required or calculated divided by what? The molar mass of the required one. Or you can use, if mass is given, you can use this formula: mass given divided by what? The mass of the substance, the given substance, which equals to mole required or calculated divided by the mole of the required substance. Okay. Here is one example. How many grams of glucose are produced when 24 mole of carbon dioxide reacts in excess water? Here, mass in grams required, mole is given. Okay. How can we find the mass? We can use the following three steps. The first step is apply the mole ratio method, in which given, you have given mole. This given mole used to calculate the required mole, and the required mole is converted into what? Required mass. Okay. So first write the balanced chemical equation. 6 moles of H2O is combined with 6 moles of carbon dioxide to give C6H12O6 plus carbon dioxide. The second step, identify the given and required one. Here we balance the chemical reaction, the combination of water and carbon dioxide that produces water and oxygen gas. Okay, the second step is identify the given and required. Okay, you have 24 mole of carbon dioxide used to produce X mole of what? Glucose. And the third step, find out the number of moles of the given and required substance from the balanced equation. That means the number of moles of carbon dioxide is the coefficient 6. The number of moles of glucose is its coefficient 1. Okay, 24 mole of carbon dioxide over what? 6 mole of carbon dioxide, which equals to question mark over what? 1 mole of glucose. In the fourth step, apply mole ratio method. Okay, as I said, the mole ratio should be the moles of the unknown over the moles of the known. Okay, 24 moles over what? 6 mole equals to question mark or X over 1 mole. And then crisscross and divide both sides by 6 mole. Okay, 24 mole multiplied by 1 mole divided by 6 mole, which equals to 2 mole of glucose. And the fifth step, you are asked to find the mass of glucose, not the number of moles. Therefore, you have to convert the number of moles of glucose into what? Mass. Okay, this is the final step. Okay, how can we convert the number of moles of glucose into mass? Number of moles equals to required mass of glucose divided by the molar mass of glucose. Required mass of glucose equals to number of moles multiplied by the molar mass. The molar mass of glucose is 6 multiplied by 12 plus 12 multiplied by 1 plus 6 multiplied by 16, which equals 180 gram per mole. Okay, the atomic mass of carbon is 12, the atomic mass of hydrogen is 1, the atomic mass of oxygen is 16. You have 6 atoms of oxygen, 12 atoms of hydrogen, and 6 atoms of carbon. Okay, when we find the molar mass of carbon, you have to multiply 6 by what? 12, and you have 12 hydrogen atoms. 12 multiplied by the atomic mass of hydrogen is 1, and you have 6 oxygen atoms in glucose. 6 multiplied by 16 is 118 gram. The required mass is 4 mole multiplied by 180 gram per mole. This gives what? 720 gram. You can use the second method, which is apply both mole ratio and mass ratio methods. This is done by using both mole ratio and mass ratio from the equation to get the number of moles or mass of the unknown. Mole given divided by the mole of the given substance, which equals to the mass required divided by what? The molar mass, the mass of the required substance, or mass given divided by mass of the given one divided by what? Mole required divided by mole of the required one from the balanced chemical equation. Okay, this is the equation. I wrote it again. Solution. The first step is write a balanced chemical equation, is already written here. Identify the given and required, in which mole is given, mole is required. Okay, then find out the number of moles. I'm sorry, this is in gram, because we use a combination of mole ratio and mass ratio method. Okay, one ratio is in mole, the other one should be in mass. Okay, this is a combination of what? The two methods. Okay, the mole is given here, the required mass is required. This is the mole ratio method. Okay, find out the number of moles and mass of the givens and required substance from the balanced equation. We have 24 mole of carbon dioxide, which is given from the stoichiometric proportion. We find out 6 mole over mole. This is the mole ratio, and the mass of glucose is 180 gram from this balanced chemical equation. Mass required over what? Mass from the stoichiometric proportion. Apply mole and mass ratio method. The mole and mass ratio should be the mass and mole of the unknown over the moles of the known. 24 mole over 6 mole, which equals x in gram over what? 180 gram, and then crisscross, divide both sides by 6 mole, and this gives 720 gram of glucose will be produced from 24 moles of carbon dioxide. The third one is the third stoichiometric stoichiometric calculation is the mass conversion, in which the mass of the reactant or product is given and the mass of another reactant or product is required. It is done by using the following methods. This one is the first method, using mole ratio method, in which you have given mass converted into given mole. This given mole is used to calculate the unknown mole. The unknown mole must be converted into what? Mass. Okay, this is the longest method used to calculate the mass stoichiometric problems. And the second method is using a combination of mole ratio and mass ratio method, in which there is what a given mass, find out the unknown mole, and the unknown mole is converted into mass. And the third method is by using mass ratio method only, which is the shortest and simplest way of calculating the mass conversions, okay, in which the given mass is converted into what? The unknown mass. Okay, let's calculate this example by using what? The first method. How many grams of sodium hydroxide are needed to completely react with 50 grams of sulfuric acid to form sodium sulfate in water? Okay, this one is the first method using the mole ratio method. First, the given mass is converted into what? Mole. This given mole is used to calculate the unknown in mole. The unknown mole in mole is changed into what? Unknown mass. Okay, we will follow what? 4 steps. That's why this is the longest method of calculating mass stoichiometric problems. Okay, the first step, write the balanced chemical equation, which is 2NaOH combined with H2SO4 to produce Na2SO4 plus 2H2O. Then convert the given mass of sulfuric acid into mole by using this formula, which is equal to 0.51 mole of sulfuric acid. This 0.51 mole of sulfuric acid is just taken as what? As a given mole. Find the unknown in mole, question mark, because you are asked to find the mass of sodium hydroxide, but we find here in mole, and you have 0.51 mole of sulfuric acid. From the stoichiometric proportion, 1 mole of sulfuric acid is combined with 2 mole of sodium hydroxide. 2 and 1 are the coefficients of sodium hydroxide and sulfuric acid respectively. Then 2 question mark divided by what? 2 mole, which equals to 0.51 mole divided by what? 1 mole, which equals to 2 mole multiplied by 0.51 mole divided by 1 mole. Mole is cancelled by mole, and this gives 1.02 mole of sodium hydroxide. This is unknown in mole. The unknown in mole must be converted into mass, because you are asked to find the mass of sodium hydroxide. How can we convert this mole into what mass? The number of, we use this formula, number of mole equals to unknown mass divided by the molar mass of sodium hydroxide. When we find the molar mass of sodium hydroxide, we use the mass of 1 mole of sodium hydroxide. Don't consider the coefficient 2 when you find the molar mass of sodium hydroxide, because the molar mass of 1 mole of NaOH is equals to 2 mole of what? NaOH. Molar mass means the mass of 1 mole of a substance. Okay, the molar mass of sodium hydroxide is, you have 1 sodium atom multiplied by 23 multiplied by what? 23. 23 is the atomic mass of sodium hydroxide. You can find it from the periodic table. Plus 1 atom of oxygen multiplied by what? 16 plus 1 multiplied by 1, because we have 1 hydrogen atom in sodium hydroxide. This will produce 58 gram per mole with the molar mass of sodium hydroxide. Mass unknown is equals to 1.02 mole multiplied by the molar mass of sodium hydroxide. This formula is obtained from this one. You can use the crisscross method to find the unknown. The unknown mass equals to number of mole multiplied by molar mass of sodium hydroxide. Okay, 1.02 mole multiplied by 58 this gives 59.2 grams of sodium hydroxide, will be reacted with 0.51 mole of sulfuric acid. In the second method is using a combination of mole ratio and mass ratio methods. This one in which the given mass is converted into mole. This mole is used to calculate the mass of what the unknown. Okay, I'm sorry. The given mass is used to find the mole of the required one. The mole of the required one is converted into mass. Okay, what are the steps that we must follow when we use a combination of what mass ratio and mole ratio methods? Always in stoichiometric calculations, a chemical reaction must be what? Balanced. This is a balanced chemical reaction between sodium hydroxide and sulfuric acid to produce sodium sulfate in water. Then identify the unknown in mole by using the given mass of sulfuric acid. Okay, you have 50 grams of sulfuric acid, which is given, and find the number of moles of sodium hydroxide. Okay, question mark divided by 2 mole equals to 50 gram over 98 gram. Okay, this one is mole ratio, but this one is mass ratio. Okay, we use a combination of two ratios and then crisscross. This will produce 1.02 mole of sodium hydroxide. This number of moles must be converted into what? Gram. Okay, by using the conversion factor. The number of mole equals to the unknown mass divided by the molar mass of sodium hydroxide, and then find out the molar mass of sodium hydroxide, which equals to what? 58 gram. The mass of the unknown will be what? 59.2 grams of sodium hydroxide is required to react with 50 grams of sulfuric acid. Okay, the third step, the third and the shortest one, the easiest one is using mass ratio method directly. We use the given mass to find out the mass of the required. Okay, given mass is used to find out the unknown mass. Okay, which has what? Only two steps. That's why this is the shortest and simplest way of calculating the mass problem. Okay, step number one, write the balanced equation, which is this one, as we have seen in the previous lesson. Number two, convert the given mass of sulfuric acid. No, this is not correct. Okay, this is not correct. Okay, the required is here. There must be what? 50 gram of sulfuric acid is given over what? 98 gram of sulfuric acid. Okay, this is the correct one, and then this is 50 gram, and this one must be 98 gram of sulfuric acid. Okay, this is the correct way. Okay, cancel this one because this is a copy paste from the previous step. From the previous step, find the unknown, and this is the second step. Okay, because it has only two steps. Okay, using mass ratio method. Okay, you have a balanced chemical equation here. Find the known, the given, and the unknown. This one is the unknown in gram, and find out the mass of 2NaOH from this balanced chemical equation. This is 50 gram given. The mass of H2SO4 from this balanced chemical equation is 98 grams. Then the mass ratio is required over mass of the unknown from the balanced chemical equation, which equals to the given mass of sulfuric acid over the mass from the balanced chemical equation. And this gives 59.2 grams of sodium hydroxide. Okay, this is all about the mass stoichiometric conversions, about mole, mass, mole, and mass conversions. Okay, thank you for watching. See you later.